Hey folks, I'm just going to quickly show you the scan processor. Now, Equalify scan processor is the main brain behind what Equalify does. So I have a VS Code window open right now, and I'm going to navigate in VS Code to the scan processor file that's in helpers. So I'll open it up here. And then now that I have the scan processor open, you can see all the different information around the scan processor. In this file, I have a little bit of commented out testing data, and I can uncomment this. So just kind of a background of the scan processor. It's going to do everything that Equalify does to get a scan from being just regular JSON into Equalify format. And this is the main piece that Equalify works on because it sets up the entire data structure for Equalify. So I uncommented the testing data here, and the testing data is referencing a JSON file path. You would, if you're doing this yourself, you would update that file path to whatever you had. And we're using a format called stream that we're developing. So if you don't know what stream is, you can check out the repo github.com/equalifyeverything/stream, and that will kind of show you the format that you'll need to create in order to input things into Equalify. So I have gone ahead here and set up a sample JSON. And then what this processor will do, I'll just quickly run down what it's going to do. It'll first trim and get rid of any kind of orphans from the JSON file. So sometimes stream data will have a lot of additional information. We're not really focused on any pass information, so things like axe core, we'll talk about passes. We're going against that because Equalify will actually keep track of it itself, so we don't care about passes. So we're going to trim out passes, and we're going to trim out anything that is not related. So if we have tags that aren't related to messages, we're just going to get rid of that right off the bat, and that's going to help speed up our processing. The next thing that we'll do is we're going to count unique items in JSON. This is just benefit for debugging. It's not anything heavy that will impact our processing, but it'll help us see what this processor is doing when we're debugging. So we're just going to count all the items in that JSON that we're going to process. And then we actually get to what the processor is doing to get information into Equalify. First, we're going to process the URL. So we're going to save that URL. We're going to see if that URL already exists within Equalify. If it is, we're going to assign it an existing ID. If it isn't, we're going to create a new ID for it. Then we're going to process its messages. So any messages that are coming in via that stream JSON file, we're going to process. And what we'll do is we'll see if there's any existing messages. If there are, we'll give them the existing URL. If there aren't, we'll add them to the database. We'll process tags, and that's again, we're going to see if there's existing tags. If there are, we'll give them the existing ID. If there aren't, we'll process them in the database. We'll do the same thing with nodes. And nodes are basically HTML snippets. They can have HTML and targets in them. This is how we know where the issues are. So we're going to process the nodes. We're going to see if any exist in the database, and then we're going to add them if they don't. Now, one very important thing about nodes is that we add a new node for every page. So you might have the same HTML on many different pages, but they're recorded and Equalify as different nodes because they all have unique page IDs. So nodes will have unique page IDs. That's very important to remember. We'll talk about it in a little bit. And then finally, what the processor does is it compares and updates nodes. So the way we can tell if an issue is fixed or not is we look at the code around that issue, and then we decide if it was updated or not. If basically the code was updated and there's no longer a violation or error message related to that code, then we say, hey, it's been qualified, and we'll log that. And that's what this function is doing. It's seeing if issues have been equalified or not. And we can also see if issues that were equalified aren't anymore. So that's what this compare and update nodes function is doing here. So let's run it just to kind of see what's going on. And first, I'm just going to run a very basic JSON file through this that we have set up here. It's just called stream sample one, and we're gonna run this on our local machine. I use something called ddev, so I'm gonna type in into my terminal ddev php and then the file helper/scan, and now I'm gonna run this file. I'll run the file, and it's very quickly told me everything I needed to know. So what it's saying here is that it surveyed the JSON. The JSON has a URL, new.org in it. It has no unique error message, no unique pass messages, one unique violation message, two unique tags, and so on. So it's telling me all the information that is in this JSON file. And then it actually processes that information. So since this is the first time I've ever run any file on the processor, it's going to add a lot of new things in. So what I expect to see is that everything that the processor said was in the JSON is added into Equalify. So again, I have one unique violation. The processor added one unique violation into the database. I have two unique tags. The processor added two unique tags into the database. I have two unique message tag relationships. This is a relationship between messages and tag, and I have two in JSON as well. Nothing was equalified because it just had a bunch of errors, and since we just did this for the first time, nothing can be fixed. And so I'm going to just run another example with the same exact data, and what I should see when I run the second example with the same exact data as the first is that it'll basically have the same information, but nothing will be new. Right now it's saying that we have one new message, two new tags, one new node, but now when we run it again, which I'm going to run right now, it should say nope, there's nothing new. It's the same count of things, but nothing is new. So the processor went through, it saw what was new, it didn't add anything new, but it went and processed it to make sure that they weren't new. In the next example, what I'll do is I'll delete a tag from it. So I'm just going to go in here and delete a tag from the JSON. So I have deleted a tag from the JSON, and what I should see is one less tag. So right now we have two tags. What I expect to see is just one tag here. And so let me run it again, and voila, there is one tag. So it's just updating the database with whatever came in through JSON. One important note is that we don't delete tags or messages or nodes in the database. We always want to keep a record of that. That record helps us in lots of different ways. One way it helps us is if things show up again, we can kind of track them over time. We can also see what types of information was available at what time, and that will help us eventually with giving our users all sorts of data on their issue and issue remediation. So again, I processed the same information, and it just processed everything. It just removed one tag, and so on and so forth. Let me add back a tag so you can see. I'll add a totally unique brand new tag that hasn't been added before. So it should say that this is a new tag, and voila, it says it processed two tags. Last time it processed one tag, but this time it's processing two tags. One is new. So it's keeping track of what is new and what is not. Next, I'll qualify something. So when I qualify something, what that means is it's deleting a node from the JSON file. So I'll just show you here on the screen what that means, because I think it's good to see. So let me pull up here the stream sample that I'm working from, and I'll show you the one before. So the one before had one node in it, so it had one piece of a paragraph in it. And so the JSON before had this paragraph, and now the new JSON that I'm going to run doesn't have that anymore. So that doesn't exist anymore. Let's see, here it is. Let's stream sample. So yep, so this one does not have a node anymore. The nodes array is empty. So again, in the prior sample, I had one node with one HTML object in it. Now I have no nodes. And what that's telling me is that no issue is now being reported as a violation or error. So the one issue that I had before, it was marked as an error because it was in the JSON. And now, since it's not there, I know that it's gone away, that it's no longer being recorded as an error for this page. And so let me just run this again, and what I should see is that one issue is equalified. Let's do that here. And voila, one issue is equalified. It's saying nodes equalified 1. And this is basically just telling me that the node was gone and that it's no longer an issue. Now I'm going to add back in that node, and what I expect when I add back in that node is that when I add it back, it's going to say that it was unqualified. So when a node is added back, so say, I fixed an issue with a heading, and then that issue popped up again because a user messed it up again. It's going to actually take that node, and it's just going to change the status again. So let me do that and run the script, and it should show one node is unqualified. It moves from equalified to unqualified. What this is also doing is it's logging when that happens, so we can have a nice chart that shows over time when things are equalified or unqualified, and so on and so forth. It's a pretty nice way to have a kind of time flow and see how many issues were fixed over time. Next, I'm going to add in a whole new message just to show you what happens when you have a new message. So as you've seen before, we've had 0 error messages, 0 pass messages, and 1 violation. So we've just had 1 violation. Now I think I'm going to add in an error message, and then let me run this again, and voila, we have 1 error message. It's new. And if I ran the script one more time, you would see that error message is still there, but it's not new anymore because it's been added to the database. And what I'll do right now is I'll add another node to this new message that I created, just so you can see. So right now there's 1 node, and then let me run it again, and there should be 2 nodes. Yep, there it is. And the one I added is new. So again, I added a new node, and just to show you the JSON that we're working with here, the JSON should show 2 nodes in it. And let's scroll down to the JSON. Yep, there's 2 nodes, 1 paragraph and 1 header. And so I have these 2 nodes in here. Again, if you go to the GitHub repo for Stream, it'll explain all of this, of what this JSON is. But for right now, you should just know that it's an HTML object. And when HTML objects are in the output results, it means there's something to look at, they're a problem that's happening, and when they're taken away, they're no longer a problem. So now I'm going to remove one of the nodes. So I've removed one of the nodes from this next example, and then what that should do is equalify the node that I added. So yes, so 1 node is equalified. And so that, I've marked it in the database as updated, it's equalified now. And what we should be going for, like the end all be all for all this, is basically an empty JSON file. We don't want to see results, because every time we see a result, that means that there's a violation. So let me just go to the JSON to show you this, but this is what we're going for, where there's really nothing. There's no messages, no tags, no nodes. That means that we have a beautifully clean result with no issues whatsoever. And so if I'm going to run this beautifully clean result with no issues whatsoever, what I expect is that the final node that is there is equalified, and then I don't have to process anything, because nothing is an issue anymore. And so let me run it again. Yep. So we didn't have to process anything. Nothing was an issue anymore, and everything is beautifully fixed. And that's what we're going for. If all of a sudden we have a new issue, and say like we have a whole new URL, so I'm going to open up an example where we have a completely new URL. It's not going to affect those issues from the old URL. Everything Equalify does is URL specific. So it's specific to the URL and the property that URL belongs to. So if I'm going to add in a bunch of new errors because I scanned in a new URL, and even if those errors have the similar node, it's going to record them as something completely new because it's a different URL. And let me run that here. And it's running it as a completely new. They're showing me that there are new nodes. It's not showing me that there are new messages or tags because I'm using the same tags and messages from the last one. The thing that is unique per page is nodes. We can always relate different messages to nodes. And we don't have to have, lots and lots of the same message. But this is the Equalify processor. You can try it out and use it if you are looking at this video right now. The processor is still in development, so it's going to be found in the latest version of Equalify. And let me just quickly show you where to find that. So if you're currently looking at this right now, let's see, it's March 21st, and it might change any day, but if you're looking at this right now, you can find the processor in version 1 RC5, and if you go into the helpers, the processor is there, and this is where you will be able to run the processor. Make sure you're in version 1 RC5 when you're running it. And then I should also note that if you're interested in stream, which is the format, if you actually want to generate some JSON, go to this Equalify everything /stream. The GitHub repo Equalify everything /stream should have it all in there. But that's it. I just wanted to show you the processor. This is really the most important part of Equalify. If you have any issues whatsoever, hit me up on Slack, or you can add an issue into the issues tab on GitHub. Thanks so much.